Factoring Polynomials, which I think should be retitled Factoring the Greatest Common Factor. So we just watched this review video on factoring greatest common factor through Khan Academy. And we're going to start off with finding the GCF, or the greatest common factor, of 3 numbers instead of 2 numbers. So I'm going to look for every number that 24 is divisible by. So all the numbers that go into 24. The more of this you can do in your head, the easier it's going to be on you. But if you can't do it in your head, if you're just not there, make sure you've got a calculator handy. Numbers that go into 24. Well, 1 goes into every number, right? It's even, so 2 goes in there. 3 goes into 24. 4 goes into 24. 5 does not. 6 goes into there. 7 does not. 8 goes in there. Not 9, not 10, not 11. Yes to 12. And after that, the next number that goes into 24 is 24. So 24 is divisible by all of these numbers because they go in evenly. Yes, question?
I was just asking because I've noticed that there's not a single greatest common factor that goes higher than half of it directly. Does that make sense?
Yes.
Yeah. So is that like a rule? Like you're never going to find a greatest common factor that's greater than what actually is half of it?
Well, half of the biggest one or bigger than the smallest number. Depends on how many numbers you're looking at. It depends on how big the smallest number is and how small the largest number is. It'll depend on a couple things. I think I get where you're going with it, though. So then for 12, right, all the numbers that go into 12, well, it's similar to 24 because it's half. It's got a lot of the same factors. 1, 2, 3, and 4 all go into 12. 6 goes into 12. 8 does not, but 12 does. Now here I do have a negative 8. We're going to focus on just the 8, and we'll worry about what happens with the negatives later. All numbers that go into 8. 1 and 2. 3 does not. 4 does. And 8 does. So now there are a lot of common factors. Right? 1 is in common and 2 is in common. But I want the greatest common factor. So the largest number that they all have in common is the 4. So the GCF for these numbers, 24, 12, and negative 8, is 4. 4 goes into all of those. Now we extend our thinking. So I used the same numbers as coefficients so that we can just build and not have to redo. But I've got, now find the GCF of 24x to the 4th plus 12x cubed minus 8x squared. We already know that the greatest common factor for numbers is going to be 4, right? So we took care of that. So now let's look at the variables. X to the 4th is x times x times x times x. X to the 3rd is x times x times x. I'm kind of doing this one in pieces here. I already took care of the numbers, so I'm not going to include them this time. All right, so greatest common factor. They all have an x in common. They all have another x in common. So when I'm talking GCF here, 4 goes into all the numbers, right? And x squared goes into all the variables. So now I'm identifying the GCF of this whole expression. Identifying the GCF is half the battle. Questions on GCF before we build on it even further? We're going to do it plenty, so if it feels like a lot, don't worry too much. But if you have a specific question, yeah. What part do you not get?
I understand how you got the X.
So I broke it up into pieces. First, I looked at the numbers. Greatest common factor is the biggest number that goes into all of the numbers that are given. So now I know 6 goes into both of these and 8 goes into both of these, but they don't go into all of them. So the largest number on the list is 4. Okay? Now down here, I'm looking for what's the greatest number of x's on each list. So I have 4 of them here, 3 of them here, 2 of them here. They all at least have 2 though. So that's where the x squared comes from, because x times x is x squared. Cool? Cool. Now I'm going to find the GCF, but I'm actually going to factor it out, which is going to take some dividing. So example 1, factor out the GCF from each polynomial. Problem A. Now this time I'm going to do the numbers and the variables all at the same time. I'm not going to break it up into different lists. I only have 2 terms this time. What are all the numbers that go into 3 evenly? Oh, yeah, 3's prime, so that's not a very long list. And then a cubed we know is a times a times a. Now, some of you guys are going to be able to look at this and do it in your head. That's great. But we're definitely going to break it down into small pieces as we move through this, okay? All the numbers that go evenly into 27. Well, let's see. 1 goes into everything. 3 goes into 27. 9 goes into 27, as well as 27 itself. A squared gives me a times a. So I'm looking at 2 things now. I'm going to look at the numbers and I'm going to look at the variables. Well, I only have the choices of 1 and 3. Oh, good. Here I have 1, 3, 9, and 7. So the greatest number they have in common is 3. Cool. How many A's can I take out? 2. Right? I got that one and I got that one. So the GCF is 3a squared. Think of factoring like anti-distributing. So we spent the last couple days practicing multiplying through. Now I'm taking that common factor and I'm pulling it out. So we're going to be doing some multiplying in our head and some dividing in our head here to work through this. So I'm pulling it out. I'm dividing by it. I'm pulling it in front. So I had 3a cubed and I just took out, I'm bringing in front 3a squared. So 3 divided by 3 leaves me with a 1. You could write it if you want to. A cubed, take away a squared, leaves me with just an a. So you can think of it as division. You can also ask yourself multiplication. 3a squared times what gives me 3a cubed? Next term. 27 divided by 3 leaves me with 9. A squared, take away a squared, there's no a's left, right? The other way to think about this, you could think of it as division. You could also think of it as multiplication. Okay? I'm not going to lie, guys. This is a complicated thing. So it's okay. We're going to get a little bit at a time. So this is 27a squared. I'm anti-distributing. I'm pulling in front. I'm anti-multiplying. I'm pulling out a 3. So 27 divided by 3 is 9. A squared divided by a squared, well, those just cancel. Or you can think of it as 3a squared times what is 27a squared?
Yeah.
Well, I've got plenty of examples.
So where did we get that first one from?
This?
Yeah.
Is that
3a cubed.
3
Take away the GCF. What is 3 divided by 3? 1.
One.
A cubed divided by a squared leaves me with 1a left over.
Oh, so what?
Oh, that
Wait,
is so cute. Okay.
So say we don't do what you just did in our head, but we like we do how like where you got the right original a's, like where the 3a squared is. Could we just look at that and see that there's like 1a left or 2a left, and that would be it?
It'll work for your list of variables, but not for your list of numbers. Right? Because I don't want to multiply like 9 and 27, right? But it'll work for your variables.
And if say there was like another a on the top, like it was 3a.
Hold on. We'll get to more examples. Hold on. It's coming. Okay. New example. B. 2x cubed plus 5x squared minus 22x. So I'm going to break down each term in that polynomial. So 2x cubed. The only things that multiply to give me 2 are 1 and 2. And then I have x cubed, which is x times x times x. Okay. Five x squared. The only things that multiply to 5 are 1 and 5 because 5 is prime. X squared is just x times x. Then I have 22x. Numbers that multiply to 22. Let's see, that's not prime. 1, 2, 11, and 22. And I have an x. What is the biggest number that goes into all of those? 1. That's all I got. Okay. So they're called relatively prime. Let's see. Are there any variables that I could take out? Just an x, yes? Okay. So my GCF is x. That's all I can take out. Now note, if I'm just taking out GCF and I have 2 terms here, then whatever's left inside the parentheses is going to be 2 terms. I'm taking out GCF. I have 3 terms here, so what's left in the parentheses is going to be 3 terms because I have to take something out of each one. Here we go. I have 2x cubed dividing by 1x. So 2 divided by 1, that's still just 2. X cubed, I take away an x, and I'm left with x squared.
Wait, why did you take away the square?
An x because it was my GCF. We decided that they all had an x in common, so that's my greatest common factor. So I'm bringing it in front. So then here I have 5 divided by 1, so that's just 5. X squared, I take away an x, I'm left with a x.
Okay, so whatever greatest common factor you get is what you're gonna
Is what you're taking out.
Oh.
You're dividing by it, but if you want to think of it as multiplication to work backwards, you can. Right? They're essentially just inverses of each other. Then I have a negative 22 x. I take out a 1 and I'm left with a negative 22. I had an x, but I took an x out.
I think I'm just starting to get.
Yes, question or observation? Go ahead. Because I have x squared.
Yeah.
The problem.
Oh,
So 5x squared, right? Means 5 times x. I'm taking an x out. I'm bringing it in front, but I'm left with a 5 and an x still. Okay. Now you'll notice, whenever I take out a positive factor, so I took out a positive x, I still have 3 terms and the signs stay the same. Positive, positive, negative. Positive, positive, negative. Right? Here, I had 2 terms. I took out a positive. They still have 2 terms, and they're both positive. Yeah?
No. Okay. I'm getting there. Somewhat. Potentially understand it, but not a lot of it.
So a rule. If the leading term is negative, take out a negative GCF. And we know that when we divide everything by a negative, all the signs are just going to change. Just like if we multiply through everything by a negative, the signs always change.
So basically, when you're multiplying them, you're just going to say which one negative? All of them?
I'll show you. Hold on. You guys are awesome. You're trying to think ahead, and I love it.
No, don't think anything. See, and what if my next, what if Gonzalez is yours?
You're going to be okay. You can come back if you need some help. Okay? Yes. All right. So I'm going to write out, what are all the things that multiply to 16? Well, 1, 2. If you weren't good at factors before, you're going to get good at it now. 3 does not. 4 does. 5, 6, 7, 8 does. 16.
Yeah.
All right. And then I've got 5 y's. I'm going to write them all out until I get really good at this. So 28. Yeah, it's even. 2, 3, 4, 7, 14, and 28. If you're like thinking in your head, I have no idea where she got all those factors from, that's what you're going to sit there on your calculator and you're going to go 28 divided by 3. Doesn't work. 28 divided by 4. Oh, good, it works. 28 divided by 5 until you get better at this. All right, so for 20. You might not be confident, but just try to write the GCF. It's okay, just jot it down. If the leading term's negative, I'm going to have to take out a negative, but I'm not so concerned about that. Maybe you got 4y squared. And bonus points if you recognize that the leading term is negative. So you actually have to take out a negative 4y squared. Okay? It's only day 1, guys. We're going to do this a lot. It's going to take plenty of practice. So I divide, right? I've got the GCF. That's half the battle. The rest is dividing. Negative 16 divided by negative 4.
Okay.
Okay. Anti-multiply.
Oh my god. Yeah, I was so confused at how you kept
Dividing is the opposite of multiplying. I did the same thing on the problem before.
Yes. You said
Multiply.
there was no. That makes so much more sense.
It's the same thing. Negative 4 times 4 is negative 16.
Yeah, I know, but I didn't understand that. You said anti-multiplier.
Okay.
And I did not put that in my head.
Y to the 5th. I'm taking away y squared, so I'm left with y cubed.
Yay.
Now I've got 28. Divide by negative 4. Check your signs. And then I'm left with y squared. Negative 20 divided by negative 4 leaves me with a positive 5. And there's no y's there, right? Now, double check. I've got a negative, positive, negative. If I'm going to factor out a negative, all my signs should change. Positive, negative, positive. So I'm good. All the signs switch, right? Just like if I divide everything by a negative, all the signs change. Or if I multiply everything by a negative, the signs change, right? Same result. So I have negative, positive, negative. I divided by a negative. So inside the parentheses, it's going to be positive, negative, positive. All the signs change.
Oh, okay. So, okay.
Just a check, right? Just to make sure you don't goof on the signs.
How would I put that as like a little side note?
Rule: if the leading term is negative, take out a negative GCF. Signs change inside parentheses.
I wrote it there. It's division. I was so
All right, next one.
I got this now. Yeah, Mom.
Negative 8xy squared minus 14x squared y. Now, throw in another variable in there, but the rules all stay the same.
I said what I said.
I know what you said.
Is it going or not to be mom? I don't know why. I don't need the negativity, okay? Does it matter really right now?
You can if you want. I usually don't put it here, but you can. It won't change much. All right, so all of the things that multiply to 8. Now I know some of you are at the point where you might not have to make this list. That's okay. You go for it. All right, 8. All the things that go into 8. 1, 2, 4, and 8. Now I've got an x and I've got y squared, so that's going to be y times y. I have an x and a y squared, so y times y for the y squared. 14. 1, 2, 7, 14. This time I have x squared, so that's x times x, and then a y. The biggest number they have in common is only 2, not so big. They have an x in common. They have a y in common. So I have 2xy. Reminder of the last rule, though. If the leading term, the first term, is negative, I have to take out a negative. So I'm going to take out a negative 2xy. Yes. Good. Me too. Okay. So I have negative 8 divided by negative 2 leaves me with a 4 remaining. And then if I look at my list of variables, I'm left with a y. I have a negative 14. I'm taking out a negative 2. So when I divide by it, I get a positive 7. And then left in my list, I've got an x. Double check. I started with 2 terms. They were both negative. I factored out a negative. So now both of the things in here are positive. Question.
So when you divide 8 and 2, you get 4, but where does the y? Why does the y?
I have x y squared, which is x times y times y. I have an x in common, and I have a y in common, so I'm taking those out and putting them in front. That means I'm left with a y. And then down here, I'm left with an x.